There's a white line. Yeah.
Well, let's just start a new one. How's that then? You've probably realized, fifth grade, that in math, there's a whole bunch of different types of graphs you can use. There are circle graphs, right? You've seen a circle graph, you've seen a bar graph. Today we're talking specifically about line graphs. Any idea why you would pick doing a line graph over a bar graph over a circle graph? When is the best time to use a line graph? Bam, Julia?
To show like what happened over time.
Okay, when you talk about time and how things change. Okay, for example, if you probably watched the weather or the news recently, okay, they might toss out a line graph to show what to do. Let's just sketch one real fast here. Okay, they might sketch out a line graph to show our beloved temperature. And you might even know our temperature. Let's just make one for fun of the temperature since, let's go Sunday. Okay, so let's start here with our, now these lines that I'm drawing right here. Okay, these lines here, the two main lines, you may know what we call those bad boys.
No.
One of them is the horizontal axis. Okay, and the other one is the,
Vertical.
yeah, see you guys. I might promote you all the way to sixth graders right off the bat. Okay, because part of what we're doing today is you guys are going to have to kind of decide how to draw your own graph. Okay, now I am comparing what two things here? When I talk about the temperature that we've had so far this week, I'm talking about the days of the week, right? And what I am talking about also is the temperature. If I can spell it, if I can get this thing to write right. So you have a choice to make here, fifth graders. Am I going to put the days of the week down here, or am I going to put the days of the week going this way? Which one makes more sense? Where would you put temperature and where would you put days of the week if you were drawing a graph there? Do I have any suggestions on that? Ryan Connor thinks
Days of the week should be like this.
you would make this, well, let's do that there. So you would say that maybe this line is Sunday, Monday.
Oh, no, other way.
Oh, that's what I thought after, yeah. Generally speaking, children, when you talk about these, okay, since the days of the week are the time, usually we put our time going this way. So then I'd have the temperature on Sunday, on Monday, on Tuesday, what do we have today? Apparently Wednesday is going to be about all we get here. Should we do the highs or the lows? Let's do the lows because they're much more exciting. The low temperatures. Alright, so my lines that are going across, the horizontal lines are going to be my temperature. Now the next thing I have to decide is, what should I label those lines going across? I know they're going to be degrees because that's temperature, but I have to decide how many degrees is this line, how many degrees is that line, how many degrees is that line, how many degrees is that line. Now here's where it takes a little bit of thought. The first thing you want to think about is, what is our range? What were our range of temperatures? Does anybody know what the low temperature on Sunday was? Let's just guess. It wasn't that bad. Sunday, it didn't get cold out until Monday morning. Sunday night was how cold? Anybody? I don't even remember, but it was probably,
I think it was like 9.
let's go with 9 or 10 degrees. Let's say Sunday was 9 degrees. And then it probably was the coldest on Monday morning. Anybody, the temperature on Monday morning?
Negative 16.
Let's go with, I like that. Monday, well, let's do negative 16. Tuesday was almost as bad, but not quite. Anybody? Tuesday was,
-2?
no, I think I got down lower than that. I think Tuesday was still in the negative
50.
12 or 11, what?
I think it's like -9, I think, on Tuesday.
Oh, I thought negative 9 this morning. What is today, Wednesday? Wait, today's Thursday, isn't it?
Yeah,
so it's-
Thursday.
Oh, well, I'm a whole day behind here. I think Monday and Tuesday were close. I'm just gonna put -12 degrees here. Yesterday we came to school, it wasn't so bad. Anybody, what was yesterday? I think it was like 0, wasn't it?
-2.
-2.
-2 is.
By the way, it doesn't really matter. But today it got cold again, because today I know I woke up and they said it was like what, -10 or something, was it? What'd you, is
I said it was like 0, like when I was going to school.
that what it said on your thing? I swear, it was, I know. it was-
0. Well, you got up a lot earlier.
I did get up a lot earlier than you did.
And I remember that.
Let's say 0 degrees just because. Because we're talking about here. So now, you go home. Yeah, I'm sure it'll be 48. Feel bad for you, Pete. Alright, so here's the deal. What is my range? What's the difference in temperatures between the very lowest one, which is going to be tough because we don't deal with negative numbers that much. We went from -16. This is getting more exciting by the hour here. Here's my 0, right? -16 goes way down here, and the highest low we had was what? 9. So how many degrees is there between -16 and +9? Who's the mathematician out there? This is kind of hard because we don't deal with negative numbers all the time. How many degrees is there? If you counted all the way from -16 to 9, how many would you have to count? Because you have to go -15, 14, 13, 12, 10, 11, 10, 9, 8, 7, 6, 5, 1. All right. The difference here is 25 degrees. Nice work on that. Because you have to go up 16 to get to 0. That's what made it so cold. We were so far below 0. And then you have to go up another 9. So my lines here have to be able to show a difference of 25 degrees. So if I have 1, 2, 3, 4, 5 lines, okay, how many degrees should each line stand for? Let's just say, here, let me give you for example. Let's say each line just stands for 2 degrees. Well, if I start way down here with my lowest, which is what, -16? If the next line up is only 2 degrees warmer, what would it be?
-14.
And then -12, and then -10, and then -8, and then -6. I can't use that because I don't have enough lines. So you have to adjust your scale to fit what you got there. So I can't use just 2 degrees. What should I use? Somebody said it out there. What would somebody say? Let's try 5. Let's see if you can use your mathematical abilities here. If I have -16 here, and the next line up is 5 degrees warmer, what is it? Okay, you guys can already do algebra type math. You just did this problem, -16 plus 5, and you said it was? Math is not that hard. Alright, so I go -11, now it gets, if the next one goes up 5 more degrees, it's what?
-6.
-6, well done. Another 5 degrees is?
1.
-1, thank you. Now it's gonna get a little tougher. 5 degrees warmer than -1 degrees is?
4.
Nice job. And then 5 degrees warmer than 4 degrees is?
9.
Okay, so there is my scale. And make sure when we do our bar graph, we label this. This is the day. What would we label this? The temp. And then we have to make our little dots and our marks here. Let's go with a beautiful color of green. So on Sunday, how warm was it, did we say? Or how cold, I should say.
9.
The low was 9 degrees. So we put our little dot there, right? That's 9 degrees. What was it on Monday? 16 degrees below 0. That's as low as we go on our map there. What was Tuesday? -12. Now we've got a problem, kids. What do I do? What can I do here because I don't have a -12 on my thing here? Mia Schwartz? Yeah, you just have to think, okay, if this is -11, wait, would -12 be above that or below that? Very good. And it's going to be 1/5 of the way or just a little bit below that line for -12. Wednesday was minus 2 degrees, which, oh boy, that's gonna be tough still too. Where's minus 2 degrees gonna go?
Right,
Just below the -1. And then Thursday is 0, which is, ooh, we don't even have a 0 there. Wait, where's 0 gonna be, above or below -1?
right.
There you go, just a little bit above. And then once you get your dots, here's one of the important parts of the old thing here, is you need to connect those dots. Let's see if I can get a nice green color for this thing. So then we take our green, goes down to there, up to here, up to there. I guess I missed that one over there. And that's the purpose of a line graph, because when you look at it real fast, which day did the temperature go down the most? You can see that right away. Madison, it's right from Sunday to Monday, the lows dropped a lot. And then you can tell from Wednesday to Thursday, there wasn't that much of a difference. We could draw, should we do one with the high temperatures?
No.
What was the highest we got in the last 5 days? It wouldn't be that hard to do. What was the, here, let's do it in a different color, because then we've got a double line graph. We'll be excited about this. You don't have to draw this, let's just do this for fun. But you should, why would you want to? How warm did it get on Sunday?
I have no idea. 9 degrees.
It was warmer than 0, wasn't it? So I gotta put my graph, let's just say it got up to, what would this line be here? 5 more than that is 14 degrees. Let's just say it got up to 14 degrees. Monday, when it got down to 16 below, it never warmed up past what? That cold day? I think it was only up to like -12 or something, wasn't it? Or -10?
Minus 13.
Let's go with -13 for Madison. So that goes right here. Tuesday, how warm did it get Tuesday? Now that second day we got off, it was cold in the morning, but it warmed up in the afternoon to like, I think 10 degrees or so. You disagree with me? How about yesterday? How warm did it get yesterday? You guys aren't much for weather.
Six.
What the hell me out here? Was it 6? It wasn't very warm. So 6 degrees is right here. And today, how warm was it supposed to get? It's supposed to get warm enough today to have freezing rain. I believe they said 37 degrees or something.
Oh.
So that's gonna be off our charts here. Okay, so then here's our line
That's gonna be.
graph for this one.
If you skip this one, then
You skipped one. What's it? Monday.
Monday, though. Oh, watch this. Down,
Whoa.
up, down, up, up.
Whoa.
And again, you know, the line graphs are just there so that you can see the amount of change. So when you see a line graph, open your books to page 384. Page 384. Band people off with you. I'm sure there won't be an assignment. Unless these other guys, hey, how about this? If there is, you don't have to do it because they were bad, not you. Not yet. Oh, we don't have time. I know, come on, I wish you didn't either. Take a look at page 384, those of you that are non-band people. Wait, is there somebody at band that's coming back? This gets way too confusing. Look at page 384, young fifth graders. You will see there that there is a line graph there. When you see a line graph, what is the first thing that you should do besides Google and ah at the beauty of it and the colors? The first thing you need to check out when you see a line, did something break? They're pretty much indestructible. Oh wait, did that? I don't know if I've ever seen that come off. Is that a battery thing?
yeah, just like that.
What's the first thing that you should look at when you see a line graph there, Sammy Bollinger? Exactly. You always look at, if it has a title, this one really doesn't, look for that first, and then look at what each of the labels are on the axes. Look for these things. because it doesn't do you any good to know what the numbers are if you don't know what the labels and what the thing is talking about. So this graph here is talking about what? What are we comparing here? What is the vertical axis? Mia? Again, it's talking about temperature. And then what's the horizontal axis? Actually, it's not only temperature, it's average temperature. In what there, Landon? In the months. So you are comparing what the average temperature is per month. Now the questions they ask you, in what month was the highest average temperature? And what was that temperature? Taking a look at that, what is the highest temperature? You have to actually look in your book for this. And notice how with the line graph you can really quickly see which one's the highest one. If those were just numbers, it wouldn't be that obvious. If they just told you the temperatures with numbers, you wouldn't be able to see the highest one right away. But right away you can look at this and see that the highest one is, Cabran, how do you know that's not June? I'm just asking. Aren't both of them? Because it goes in, how do you know it's not January? Alright. I'm good with you, Cabran. So what is the temperature there? And also make sure when you look at those labels, you look and see what each line is worth. On this graph, what is the increments of those lines? Each line is worth how many degrees? 2. 10 degrees. The lines go from 0 to 10 to 20 to 30. So each one is worth 10 degrees. So Cabran, what was the exact temperature in July? Well, now, what do you think? Are we in agreement on 71?
I think it's 74.
Okay, now there is no exact right answer because they don't cut the line into little tiny 10 pieces, so you don't know for sure. But it's probably, some of you said 73 or 74. Okay, and again, it's kind of a guess because they don't give you the exact number, so I couldn't come and say, well, you're absolutely wrong. I would say you're wrong if you said 70 degrees because it's obviously not on the 70-degree line, okay, but it is a little bit above it. But you have to kind of guesstimate what it is. How about number 2? What was the range of temperatures shown in the graph? What's the difference between the highest temperature it showed and the lowest temperature it showed? You might actually have to scratch out a subtraction problem there. First of all, what is the highest temperature? We already said it was 73 degrees. What's the lowest temperature there? 30. So if you do that subtraction problem, I know you're mathematical wizards enough for this. Brooke, how? 43 degrees. That's what I have here. And then number 3 says from March through June, the average temperature increases about how many degrees per month? From March through June, about how much does the temperature every month go up? Does it say what city this is? It does not.
No, I've got it on
Does it say what city we're talking about?
the city.
Or what country or what county? I just was wondering. How much does it go up per month, Sammy? 10 degrees. Well done. Well done. What do we got? 10 minutes left. I do want you to do something, but it won't be bad because it's making a graph. Oh, I do have it up here. Oh, but how am I going to do this here? I'm going to give you a piece of graph paper so you don't have to spend your time doing your own.
Yes.
We are going to graph the population of Illinois.
Oh, wow.
That shouldn't be hard.
That's
With a line graph.
Wow.
How do you see if you
Yeah,
can
that's
figure
really,
this
really,
one out?
really rapid. Probably line.
The real question is, can I do both of these at once?
7 million, and then 11. This isn't this. That's not even now. 14. They only I bet you say now. We're only gonna have even more rapid 15 million or something.
Yeah, you're only going to use one of these. I'm going to see if I can get both of these things up at once. Hold on a second. sure I can.
2014.
Wait a second. Oh, I don't think I can. Can I? Is it here? No. Is that it? No. Wait, don't worry. I don't see it anymore.
Maybe you can scroll.
You know what? I'll just make it, I'll just kind of wing mine. I'll just throw it out here like this.
Just draw.
Yeah, I'll just draw it. Let me take this picture here. Alright, so the first thing we have to do is, you've got the little graph, we're just gonna use that top one there. The first thing you have to decide is, what's gonna be the label for the bottom, and what's gonna be the label for the sides. Okay, are we gonna put the population down here, or the population going up? So write that in your label there. So write population. Mine doesn't write very well on this.
There's one on the side.
What's that?
There's one on the side copy.
I don't know what that means.
There's a title.
Oh, well, the title you'd have to put up there, population of Illinois, sorry. On top, very top of your thing, we're talking pop of Illinois. Okay? Let's label the easy parts first. You've got these lines going this way, what are we gonna label those lines? What are those? Very good, it's the years, and they go by tens. So please make sure we're starting with what year? Start with 1940 here, and then label each one 1950, 1960, 1970, 1980, 1990, 2000, 2010. All those are gonna go in that bottom thing there, right? You with me? Right here, you need to write. You've got all these vertical lines on your thing here. Okay, 1940 is going to be the first vertical line. Then 1950, then 1960. And please don't, children, don't write them in the spaces. Write them right directly under the lines. Good, just like Landon's got right here. That's what you're going to do. Everybody got that? Here is where the trouble comes in, children. I don't have 7 million lines on my paper, so what am I going to have to do? Here's where the part of the graphing thing that takes a little thought. I don't have 7 million lines, so what am I going to do with my horizontal lines? How am I going to show that? How am I going to draw those? 5 minutes and counting. I still think we'll finish. Alex?
You're going to start with 0 and then go up by millions.
Well, now, if I started with 0, do I have enough to start at 0 and end up with, I have to go all the way to 12 million. Do I have 12 lines? Don't have 12 lines, so I got to adjust my thinking. I got to try something else. Maggie?
Start at 7.
All right, I like it. Okay, if I started with this bottom line, wait, do I have enough to go 7, 8, 9, 10, 11, 12? I think so. On graphs, children, are there any numbers below 7 million? No, so we really don't need all of that part of the graph because you're not going to have any parts to it. So graphing people will do this. They'll put a little swiggle line like this to show that the graph was actually cut off and they took out some of the pieces you didn't need. So then you could start with this being 7 million. You could put 0 down here, that's fine. And then we cut off a whole bunch of the graph that we didn't need. And then 8 million, 9 million, 10 million, 11 million, 12 million. Hopefully there's enough for all that, is there? Perfect. Well, and you could make each one worth 500,000, but that'd be a little tedious. So now I'm going to let you pick the places for these. In 1940, where would 7,897,241 go? We don't have an exact point for that, but you should be able to guesstimate pretty close. Is it going to be closer to 7 million or closer to 8 million? So you just put a little dot that, don't touch the 8 million because it's not there. You go ahead and fill in the rest of the graph there. And then take your ruler and draw the straight lines to make the lines. What? Oh, you can't see these numbers? Well, how about this? Better? Perfect. Took about 3 minutes. So sorry to rush you. You get your dots first and then you can draw your straight lines last. Yeah, you're not going to use, you can put 13 and 14 and not use the top part of the graph. You don't have to use all the lines. We just gotta do what we think is best. Just think, how many of you were alive in 2010? Notice how that number would be, if Madison wasn't living in Illinois, that'd only be 12,654,543. You are that fourth person.
Disappeared.
Finish it. You gotta get those numbers.